All right, so we're now recording. If any of you had any questions for the class, as far as I know, the email went out yesterday for the groups. Is everybody clear? Are we all on the same page on what we're doing with the groups?
So when are we starting the group work?
You can start the group work this weekend. So you should have the assignment in week number 4 for assessments. So if you go into week 4, the assessment and the group project, it'll tell you what we're looking for this week, or for next week, I'm sorry. And that's due by Sunday. I only need one submission from somebody in your group. I don't need everybody to submit that assignment. Now, for the peer evaluation, I'll need everybody to submit one for credit. Okay, so everybody in the group. So group project, just need one submission. For the peer evaluation, I need everybody to submit. Does that make sense?
Yeah, and you already put us in groups? You made the groups?
Yep, groups are, you should be in groups. If you want to see what group you're in, just go on to under D2L, content, and group project discussion, and it'll let you know if our name is misspelled on the group list. Is that going to affect grading? It will not. Dominic, was your name incorrectly spelled? Okay, let me. I'll make a note of that, and it will not affect your grade. I promise you that. If you're signed up for the group, you're good to go. All right. Any questions?
I do have a question. You put out an email. I think it was the day before yesterday. It was talking about a sleep or dream journal. Like, what is that, and what do we have to do for it?
Okay. So for that, for that's week 4, right? Under week 4.
Yes.
Yep. So what I recommend doing is, because this is going to take at least, I would like to at least have 3 days, as far as, because we're going to talk about dreams and sleep patterns and stuff that next week. However, for your assignment, I just to kind of coincide with what we're going to be talking about in our lecture and in our topics, I want you to kind of just be aware of where your sleep patterns are and dreams. So you're going to be logging that in that journal throughout the week. I'm looking for hopefully at least 3 days. You know, if you don't get quite the entire full week, that's fine. But if you can at least get 3 days, I think that would be adequate. But start thinking about that on Monday if you want to try and get the entire week in, or if you're at least just want to get 3 days in, and then that will be fine. Okay.
Okay.
Good question, though. I should make a note of that. Do we have Bree in here today? Don't think we do. Okay. All right. Any other questions?
Our group project, is that due this Sunday or next Sunday?
Next Sunday.
Okay.
So you got some time. Highly recommend getting into your group, into the discussion, and introduce yourself. Just say hi, and maybe talk a little bit about how you think you can communicate most effectively. Some groups tend to get into phone conferences or get into Zoom conferences together. If you want to do that, that seems to be the most popular way. A couple of them do communicate exclusively through the discussion post in D2L. That's up to you. You know, however you want to communicate, whatever's the best for your group, I leave entirely up to you. Okay, so there's no requirements for that. All right. Any other questions?
Another question about this week's assignment.
Mm-hmm.
Okay, so the other day I was talking about to you about like the picture and everything for the infographic. Do we need? I forgot to ask. Do we need a reference right underneath of the picture, because I already have a reference of the picture.
Okay. I think you froze, Alina. Or are we still moving, or am I frozen?
You're moving for me.
Okay. Great. So Alina, let me answer that. If you want, are you back with me?
Yeah, I'm sorry.
Oh, no, that's okay. So let me get my microphone a little closer here. So with the picture, there is an APA way to do that. I'm not going to be too concerned. So as long as you reference where you got the picture in your reference page, that'll be adequate enough. Don't worry about doing the table setup with APA. I'm not going to worry about that. Okay.
I was just saying, like, do we need it like under the picture, or could we just like say that, like, because it's from the same website that I used.
Okay. Yeah. If you want to do that, that's fine.
Okay.
Okay.
All right. Thank you.
Yep. Any other questions? Okay. All right. So let's get started with, so what I wanted to cover today, because we talked about sensation last time that we met. Sensation is getting all the information in through our receptors, whether it's our visual, whether it's our auditory, our touch, our taste, our smell, whatever. Once we get that information in, those sensations in, our mind tries to make sense of it. It tries to do things and manipulate it so that we understand what's going on around us. Because remember, we're trying to identify these new stimuli as friend or foe. So to that end, we use a process that we call perception. Now, perception is taking those sensations in, organizing them, and interpreting them to mean something, to provide some kind of meaning. So I'm going to share with you my screen here because I've got a lot of examples of some of the theories your book went through, and there were a lot of them. So I'm going to try and cover as many of them as I can today with demonstrations, just so you have a good sense, because some of this ties in with your assignment. You're asked to pick one of these theories with an optical illusion of your choice and describe that, okay? So to that end, we have what we call perceptual constancy, okay? Is my screen flashing?
Yes.
I wonder what's going on.
Yeah.
Sorry.
It's like pink.
Yeah, I don't know why it's doing that. Constancy. It's been working great all week. All right. So perceptual constancy, we look at 3 different realms. We look at size constancy. Sorry about the flashing, folks. Shape constancy, and brightness. Now, what this means is that our expectation, what do I mean by constancy? Constancy means that we, based on our experience, we expect the size to always be the same on some items. So for example, if we look at a two-dimensional drawing of a door, sorry about my drawing, folks, okay? So we'll call this a door here. Based on that door, we know a door is what shape on the surface?
Rectangular.
Rectangular, right? So if we were to draw, and again, this is still considered two-dimensional, we get the expectation that that door is now moving, right? Because constancy tells us that that door is always the same. The only thing that really changes is its position, all right? So that's size constancy. I'm going to play a quick video for you to kind of demonstrate size and shape constancy and how it can really mess with our perception of what's happening around us. Let me see if I could find there we go. Oh, let me. All right, so I'm going to watch this demonstration quick.
Does what we see correspond to what's really out there? Or does our brain construct its own version of reality, one that does not always match up with the physical universe? Check me out, for example. I am the same size here as I am over here, but over here I look much larger. No, it's not a cheap video trick, it's a trick on your brain. Here's what you're seeing. The me over here is indeed projecting a smaller image onto your retina, the region of light detecting cells at the back of your eye. All else being equal, smaller images mean smaller things. Here, I'm in no danger of hitting my head on the ceiling. But over here, I am ducking. Ceilings are useful visual landmarks for judging size. Of course, you're making these size estimates based on the assumption that this room is ordinary and box-shaped. You assume the back wall is perpendicular to the line of sight, so the two versions of me are the same distance away. You're also assuming that the floor and ceiling are level and parallel. But as you probably guessed, this isn't the case, and the room isn't box-shaped at all. It's trapezoidal. The back left corner of the room is much farther away than the right. Since I'm farther away over here, my image is smaller, although I'm definitely not. The ceiling cue is also misleading. The floor actually slants upward and the ceiling downward from left to right, making my head much closer to the ceiling when I'm over here. Why couldn't you see these things and adjust your size estimates? The room's features have been cleverly distorted to be consistent with a rectangular shape. The checkerboard pattern on the floor gets finer grained toward the right, so that the same number of pattern elements fit in a shorter distance. The windows are resized and shaped to match the trapezoidal back wall. Your narrow angle of view from the front of the room blocks the cues that would reveal the room's true shape. And of course, we easily believe in a box shape because that's the shape rooms normally are. This clever setup is called the Ames Illusion. American ophthalmologist Adelbert Ames Jr. devised it in 1934 and built a physical example the following year. For Scientific American's Instant Egghead, I'm Ingrid Wickelgren.
All right, how many of you have seen that before or something similar to it?
I have.
Yeah, yeah. So what that shows is that demonstrates two things that we talked about, size and shape constancy. So we expect that room to be rectangular or square, right, in certain parts. And indeed, it's trapezoidal. We also expect that the windows and the doors and the features of the room are going to be constant with what we're able to see. So if a door is shut, then it's going to be more rectangular as opposed to if it's open, it's going to be more trapezoidal. So a lot of things going on there with size and shape constancy, but that's what and again, it's based on our experience. We know that rooms, the environments that contain people or other objects should be pretty constant with what we see in daily life. So when anytime anything differs from that, it really messes with our mind. In fact, instead of making sense that one person is a giant in that room, the other person is maybe smaller than that other person, we flip that around, right? We look at the possibility that a person is a giant in that room. So it's kind of unique how our minds can kind of just play a trick on us there. One of the other examples I have is for brightness constancy. So brightness constancy, put simply, describes that we expect something to be the same color based on its position in lighting. So what does that mean? So for example, if you are walking around at night and you see a red car go by, a fire engine red car go by, it's probably going to be a darker hue than what it would be during the day, right? Because that's what we expect. Our environment tells us so. So a good demonstration that I have for brightness constancy here is I'll show you here. Hopefully you can all see this. Can y'all see the cube?
Yeah.
Okay. So if you look, and I know many of you are probably looking on your phone, but for those of you that can see it, maybe zoom in, you have three tiles listed here. You have A, B, and C tiles, okay? Which one do you think is lighter in color or in hue?
B?
B? Right here?
You said lighter, right?
Yeah. Which one looks lighter?
B.
B, right? Right, because it makes sense to us that this is in the shadow, and so this would look a little bit brighter than A or C. But look what happens when I eliminate our visual cues around that. Can you all see that?
Yeah.
So does B still look like it's lighter than A and C?
No.
Looks like it's the same color, right? And that's because, again, I remove the visual cue. So we expect around B to be a little bit darker because it's in the shadow based on the position and three-dimensional properties of the cube. But when we remove that shadow from our minds, we can see that it's the exact same color. I have another example here. So what would you say the surface area of A or the surface area of B, which one is darker than the other?
A.
You think A is darker than, okay. It looks that way, right? Because we know, where does light come from? Where are we used to light coming from?
The top.
The sun, right? The above. So it looks like here we have a horizon with a blue sky, which would indicate to us that it's probably daytime. But look what happens when I remove those visual cues. Again, no camera trickery here. You all see that? Do they look the same shade now?
Yeah.
Yes.
So all we did was just remove the environmental cues that tell us what these size and shapes should be. Pretty cool stuff, right?
Yeah.
All right. So let's talk about another principle is that you learned that you looked at in your book is Gestalt Principles. Now, Gestalt is it was an explanation of the Gestalt Principles is an explanation of how we take smaller cues from our environment to build bigger pictures and kind of organize our thought. And when we get into learning, we're going to talk a little bit more about that. But just for your explanation today, let me share my screen with you again. Share. Hopefully this one won't be nearly as jumpy. All right. So the first part that we have is called the figure ground, which I don't have an illustration of this here. So our figure ground is the relationship, or the relationship refers to the tendency to perceive objects or figures as existing in some background. So for example, your book showed a picture of a waterfall and rocks and trees. We know that the things that are probably bigger in our view are blocking the things that are further away, right? So we know that, again, that we grew up born into this world understanding that light comes from above and that things fall to the earth. So based on that, we can kind of estimate what is in location, what's closest to us, what's further away, what's within our periphery. So all those are talked about in Gestalt's principles with figure ground. The other two principles he talked about was proximity. So proximity, oh, where is it? I am sorry about the flashing. I don't know why this happened, decided to do this today. But proximity is the tendency to perceive objects that are close to one another as part of the same grouping. So for example, maybe some of you are looking at this horizontally, right? Maybe you're seeing rows. Maybe you're seeing cubes, like not a cube, but a square here. But we're organizing based on whatever our point of reference is. But these are all the same color. These are all the same distance. So depending on how we move those around, you might see different patterns, okay? We also look at similarity. So similarity just describes how we organize based on similar properties. So many of you, I talked earlier this week about football. So within football teams, we have similar jerseys, right? We have similar colors of jerseys that our players wear on the field. That's similarity. We can judge what our team is. We can identify who our team is based on the colors that they're wearing, right? And we do that. We can do that with shape. We can do that with size. But we organize based on what we see. Okay. The other principle in Gestalt talks describes the tendency to complete figures that are incomplete. How many of you can see two triangles within that visual there?
Me.
Yes.
Right? Even though we don't have anything really connecting these, like, oh, that's not what I meant to do. We can connect them with our mind to see triangles. And maybe some of you can see the whited out triangle here as well, right? So that explains the principle of closure. And as you can see here, even though we just have little dashes off to the right where we're talking about closure, we can still determine that these are a circle and a square here, okay? Some other principles are continuity. I'm not going to go too much into continuity, but essentially, if we have two different events that overlap in timeline, we can kind of associate that with that. Maybe some of you, and this is kind of a cool example that I use for continuity. I'm a movie buff. I love movies. I love watching movies and figuring out who the actors are. Anyway, so I can remember movies from where I saw them anywhere in the world. So traveled around for the Air Force, and a lot of the movies I can remember seeing in Florida, or I can remember seeing in Texas or in Ohio, wherever I was, I can remember that. And based on my history of being in the Air Force, I can tell approximately what time frame that I saw those. So for example, if I watched Jurassic Park, I saw that in the theaters, I knew that I was in a certain town during 1999 when that movie came out. And so that's referential, that's continuity, that explains continuity. I'm taking two timeline events and putting them together to come up with perception, my perception of time, okay? Here's another example of continuity, or I'm sorry, closure. So how many of you can see, oh, my video stopped moving, sorry. So how many of you can see a cube within that box?
I can.
So we didn't do anything trickery here. All we have are a bunch of circles with shapes on them, but they're organized in such a way that we can see the cube within that, right? Pretty cool, right? But that's our mind trying to make sense of the world around us. And we do this a lot as far as, especially when we get into goal setting and reasoning. We connect two dots together and make patterns out of things. So that way we can assess what's going on in our environment. All right. All right. So some other perceptions that I want to talk about here that we probably deal with in everyday life. For the picture above this, it explains inner position. If you remember, inner position is the assumption that an object that appears to be blocking part of another object is in front of a second object and closer to the viewer. So for example, in this picture here, we have rocks in the foreground. So we can assume that the rocks are closer because we know what a tree looks like and we can't see the entire part of the tree. So we make the assumption that the rock is closer to us. We also have a principle that we call linear perspective, okay? Now, the linear perspective simply explains that the assumption is that something that is closer together in the distance is probably further away, okay? So for example, parallel lines, what we see with railroad tracks, the closer they are together, we might assume that they're further away, often off onto the horizon, okay? Another perspective that we consider in relative to perception is relative size. which is explained by the picture up here, okay? So we know what the average size of a human would be. And all these runners, we can assume that they're probably relatively close in size from each other. So this guy off in the distance looks smaller, which tells us he's what? Further away, right? We also have another principle would be texture gradient. So we look at texture in reference to how we're viewing things. So we're going to see greater texture in the water, in the rocks here, than we would off in the distance, right? Yeah, if that makes sense. So these mountains don't have nearly as much texture. Therefore, we assume that it's further away. We also have the aerial perspective. Oops. So the aerial perspective tells us that there's more of a haze on distant objects. So as you can see out here, the haze. Less hazy up front here. We've got a clear view of the trees, right? And lastly, we have motion parallax. So motion parallax parallax describes things that are further in the distance while we're moving, and we know that we're moving. Parallax. Things in the distance are going to move slower than things that are probably closer to us, right? They're going to zip by. So if you can imagine these two kids, I'm guessing, are looking out probably a train window or a bus window or something. So things in the distant, they're going to see a little bit more constantly, right? As opposed to something that might be close by to what they're going to be moving by. So for example, the sheep off to the right here is probably going to fly by them at a much faster rate. So that gives us an indication that we're moving, right? All right, so within vision, what we can look at is what helps us to determine also distance is binocular binocular cues and depth perception. So we get those off of two things. First of all, we can see that with the binocular cues, which just tells us that we're going to see the picture differently from a distance. Okay, so for example, we might see more of a right side of something that's in our left view as opposed to something that's in our left side. We're going to see more of a right side view of it. So that gives us an indication of how far or what our depth perception is. Another way that we determine how far something is the strain on our eyes. It's something we call convergence. So if we have to cross our eyes to see something, that tells our brain that we're probably looking at something very, very close because our eyes have to strain to meet that object, right? And of course, we're always using binocular cues, so that even gives us a little bit more depth, okay? All right, any questions up until this point? All right. So top-down and bottom-up processing. We're going to talk more about this as we get into cognition and how we process things and memorize things. But top-down looks at what we expect to see based on what our experiences are. Okay, so for example, top-down processing, well, let me start with bottom-up. Bottom-up processing involves analysis of smaller features building up to a complete perception. So for example, what do y'all see in that picture?
A B.
A letter B?
Yeah, the letter B.
Okay, anybody else see anything differently?
13.
I see 13.
You see 13. Okay, so we all see something a little bit differently, right? Maybe it wasn't super recognizable when we first showed that to you. So what we're doing with bottom-up processing is we're taking the stimuli, the stimulus, and we're identifying features of it. And we do that because we're waiting for more information to follow. We want to know what is that exactly. And some of you may have already guessed that that's either a 13 or a B. Now, if I gave you contextual clues, for example, oops, I didn't want to do that. You can clearly see that that would be a B, right? Your mind can't really see anything else because now we have surrounding clues, contextual clues that explain that. Or some of you saw the number 13. So if I did something like that, now you have undisputed evidence that that is the number 13 because it's surrounded by contextual clues, okay? So the stimulus identifies features and builds to the idea, builds up to the idea, the big picture, okay? All right, opposite of that. If we already have an idea, we already have big picture in mind. So for example, oops, big picture. So let's assume that you're driving in the hills of the Poconos late at night, and you see two little glowing eyes off in the distance. What do you do?
Make a run for it. Like
I'm driving. You're driving. So yeah. So what do you do if you're driving and you see two beady little eyes off in the distance that are glowing?
You probably stop to observe it.
Okay. Why? Why would you stop?
Because like you want to know what it is. You don't know like if it's an animal or if it's like a person. So you would want to stop and investigate.
Okay. Given what we know, and anybody that grew up in this area, grew up in the wilderness of Pennsylvania, I say laughingly, you might think that that is a what? What is your first thought?
Deer.
A deer, right? And we know deer come out at night, and we know that we have a harder time seeing them at night, so we're going to slow down and investigate further. But within that context, we already have conceptualized that we might be seeing a deer off in the distance before we know that it's anything else, right? So we're taking big picture ideas, and now we're going to seek evidence to support what we're thinking it might be. So we're taking the big idea that it's nighttime, we're seeing something off in the distance, and it might be a deer. And then we start scanning, we start slowing down and scanning our environment to see if indeed it's what we thought it was. So we seek evidence, we take the big picture, and we seek smaller stimuli. Whereas bottom up, we're taking the stimuli to build a picture, and then we get the big idea behind it. Does that make sense? And when we get to cognitive, again, we're going to talk a little bit more about that. What do y'all see in this picture? Oh, it stopped again. It's frustrating. I don't know what's happening today. My apologies. All right, what do y'all see in this picture?
I see a face.
A man
See if-
playing a saxophone.
Okay. So again, we're kind of using, whatever was the first thing that you see, you're going to say, I put a picture up there, and you kind of see the outline of a face. So if the first thing maybe you looked at is this is an eye, then you're going to start building evidence concerning well, what is this exactly? So if you view that as an eye, then you're going to probably start building the face around it. Okay, so that's bottom up processing. Top down is assuming, like if I told you the next thing that I'm going to show you is a face, many of you would probably see a face much more easily than you would see the guy playing the saxophone. Do y'all see the saxophone player? Does anybody
Yes.
not see,
Yeah.
anybody not see that?
I see the man playing a saxophone, but I also see the face, like to the right.
Okay.
The nose and the parts of the saxophone are like the nose and the mouth sticking out with the eyeball
Yeah.
outlined.
Yeah, exactly. So anyway, part of your or your assignment for this week was to find something. Find a. Did any of you find any cool stuff out there?
I did the illusion called a Hermann Grib, and what I noticed is that when you look at a specific like spot, it turned like there's a gray spot. When you look at it for a long period of time, it will turn white, and then from your peripheral vision, you'll see that the other like dots, they will suddenly become like gray. And when you try to look over at the other ones,
Okay.
it almost like switches, where it's like you see white and then it turns gray on the other side.
Okay. Okay. Yeah. So that's probably that you have a couple things going on there. You have your sensation because of your cones. Looking at those two colors so close together, it almost looks like it's in motion. And there's a reason. I wish we could have we had enough time to get into all of these things. But your task this week is to find these optical illusions, similar to maybe some of the things I showed you today, and explain them based on Gestalt. I mean, is it size constancy? Is it motion parallax? What is it that we're seeing in that? Okay. Any questions on perception? Or anybody have anything they want to add? All right. All right, very cool. I'm looking forward to viewing your whatever it is you find out there for these optical illusions. So make sure you get that in, I think, by Saturday, and respond to another students by Sunday. This is not a Dropbox style. It's more of a discussion forum, but very similar to what we did in week 1 for uploading it. So upload your file, and you can either discuss it in the text box, however you want to do that. And then respond to another students by Sunday night, okay? All right, if there are no other questions, I'm gonna hang back for just a few minutes here. I hope all of you have a wonderful weekend. I will see you here bright and early, well, not bright and early, 1 o'clock on Monday. All right, have a safe weekend, everybody.
Have a good
Have a
one.
nice weekend, everyone.
Thank you.
Bye.
Bye.